Good afternoon, and thank you for attending our presentation today. My name is Barron, and I'm the project manager for this team. And my teammates are Ben Baser, Blake Parrish, Jackson Marshall, and Joey Ellis. This semester, we've been working alongside ArcBest Corporation on our project. And our 2 points of contact are Trenton Kaysen, who is a lead logistics engineer and yield strategy, and Alex Hogue, who's a pricing and supply chain manager. So the focus of our project is on automating and standardizing processes that support ArcBest pricing engineers and their yield division. The pricing engineers will receive bids from the sales team and create an offer that will eventually get returned to the client. So in the following slides, we'll give some background information on ArcBest, introduce our system of interest, and explain how we improve the system, as well as how we are measuring that improvement. But before we go any further, we'd like to hand it over to our industry partner so they can say a few words about the project.
Hey, thank you. I appreciate it. So we're really excited about this project in particular because it affects a really kind of painful point in our system. So this process is touched by a lot of users, not just the pricing analyst, but an admin team, our database team, and our publications team. And each of those teams today has to take the information, transform it, and that can be painful, and it can also lead to quite a few errors if people aren't careful, or if they're just really busy. So this process that this team's come up with, it should help improve, turnaround time, because it's standardizing the process as well as reducing errors. It's been a really good time working with the team. I'm really excited because the solution that we worked with is going to be easily implementable. I think we can plug it in with a week or less, and this will have long-lasting change throughout the yield organization. So that's really exciting. And one additional benefit is that the admin team that primarily checks for errors in this process is due to shrink by about 50% in the next year or two due to retirements. So standardizing this is going to be a real boon for the people who are still left on that team too. So it's been a great time working with this team.
Thanks, Trenton. So ArcBest is headquartered in Fort Smith, Arkansas, has around 13,000 employees, and grossed about $3 billion in 2019. Founded in 1923 as Oklahoma Transfer and Storage Company with only about 10 employees, ArcBest has been growing their resources since and has required and retained both ABF Freight and Panther Premium Logistics in their growth process. They transport freight all across both North America and Mexico by land, air, and sea, and they're able to do this by delivering integrated logistics solutions for a variety of supply chain challenges, and they lean on each of their subsidiaries to bring new solutions to new challenges. ABF Freight handles all less than truckload services and is the main source of revenue for ArcBest. Ground expedite solutions move through Panther Premium Logistics. UPAC focuses on final mile and household moving services. FleetNet focuses on vehicle maintenance and repair. ABF Logistics is more of a full truckload service. And ArcBest Technologies is a newer company that focuses more on in-house digital solutions. Our project deals mostly with the yield division of ArcBest and the pricing team, whose work encompasses all of the ArcBest suite. Now I'll talk a little bit more about how business is taken in at ArcBest. The trucking and logistics field relies on customers to submit information about potential business with the company. These are commonly referred to as bids, and within ArcBest, the bids are also part of a larger umbrella term called Pricing Proposal Managements, or PPMs. Now, bids will contain information about the customer and details about a shipment. In our meetings with Trenton and Alex, we got to see what the process looks like for an engineer as they handle a bid. They use modified Microsoft Access tools and a special in-house tool called the Pricing Systems Gateway, or PSG, to handle the bids in their workflow. These two tools are where much of the bid work is done within ArcBest, in addition to the other usual business tools of Microsoft Office. In general, this usage of some type of database and a custom company tool such as the PSG is common practice in this industry. Each customer for ArcBest has different requests and numbers, but they're all handled through one of three types of bids in the company's system. Larger companies generally use a formal bid or a web bid depending on their past relationship with ArcBest and the ease to which a written offer can be handled at the time. Formal bids generally take the longest since they're the most comprehensive and require more reviewing, whereas informal bids are just what they're called. They tend to be more informal. They'll require the same analysis, there's typically less reviews, and they're generally submitted by customers without any prior experience to the ArcBest bid process. Now, web bids fall in the middle of the other two because the length can vary more and there's fewer of them to base information off of. Since the customer inputs information online themselves, the amount of information submitted tends to change based on the customer and can therefore impact the time required for the bid process. Now I'll pass it to Joey to talk more about this actual bid process.
Yeah, thanks, Ben. Our data comes from a spreadsheet log of ArcBest customers' bid packages from 2015 to early 2020. The data has timestamp columns that allow us to create new data features for each PPM, and those form the basis of all of our preliminary analysis. As previously mentioned, these bids are what the engineers at ArcBest use to make decisions about pricing and feasibility. The main process we are interested in involves many different departments, but the yield division performs the major task of receiving and returning bid offers. The swim lane graphic on the screen shows a high-level system flow of the bid process. As Ben just mentioned, there are in fact multiple types of bids, but this diagram shows a generalized process for most bids. The biggest thing the bid type would change with this specific diagram is only the removal of the marketing team's lane and the dress-up bid offer box. The first step to the system of interest normally begins with the sales team, and the sales team will submit a pricing proposal to a pricing engineer who performs all the analysis on the bid package. After the pricing engineer creates the bid offer, the bid is then presented to the customer. If the offer is accepted, the publication team will finalize the bid details prior to the customer beginning to ship with ArcBest. The scope of our project lies in the pricing engineer lane, the second lane from the top on your screen. When a pricing engineer is missing information that they need for their analysis, they must submit a request for information, or an RFI, to the sales team, which enters the bid into a sort of idle period called suspense. While the bid is in suspense, the engineer is simply waiting on the sales team to gather the missing information from the customer as requested in the RFI, and they cannot perform any analysis at that time. The fishbone diagram shown on the screen shows many of the different factors that all come together during the bid process. One of the biggest challenges we have found initially was a lack of standardization in the way that the customers submit their data to ArcBest, and that resulted in around 88% of bids requiring suspense, which means significant amount of time that could be spent on analysis is actually being wasted. Introducing standardization is not as easy as it may sound, though, unfortunately, because many customers will put together bid packages that are sent out to many different transport companies at the same time. Customers do this sort of mass distribution instead of individualizing each bid package, which sort of eliminates the possibility of a template data form that ArcBest could request from their customers. However, new standardization alone may not solve ArcBest problems anyway. There could be underlying communication issues that could prevent standards from functioning properly. So now that we understand more about the background of the system, Blake is going to get us started in the ways we've measured the system's performance metrics.
Thanks, Joey. Now that we've discussed how the current bid process functions and identified some of the main concerns as seen in the previous slide, I'd now like to discuss the current system performance. The only performance metric that ArcBest currently uses is whether or not the pricing engineer has created an offer and the offer has gone through to the sales and marketing teams and back to the customer on time. To track this, we plotted when the pricing engineer submits the offer to the client, subtracted by the client set due date, and the results can be seen on the chart on the screen. The bids to the left of the red line are considered bids returned on time, and the bids to the right are bids that are returned after the client set due date. It was found that 61% of bids were returned to the customer prior to the set due date. It is important to note though that due dates can be pushed back in some scenarios, and the data that we were provided does not account for circumstances where the due date is pushed back. Thus, the 61% of bids returned on time metric is most likely to be an underestimate. It is clear that this metric is the main interest to ArcBest, but from our perspective of trying to evaluate the true efficiency of the system and its individual processes, just the one performance metric is not enough. Later in the presentation, we'll be discussing two other performance metrics that we've developed to further analyze the system. So as I just mentioned, ArcBest currently returns around 40% of the bid packages they receive back to the customer after the initially set due date. Obviously, ArcBest does not want to return any of the bids past the due date because doing so might lead to them not winning the business. So once we knew the performance on this front, we wanted to understand what could alter it. From the data that we were provided, we took a subset of features and used this random forest algorithm to create a feature importance table. I'd like to point out that we were not interested in actually making a prediction on whether or not a bid would be late. We only wanted to understand the relationship between the features we had and whether or not the bid was late. So the random forest algorithm was a good solution because by default, it provides us with a feature importance ranking, also known as the Gini index. From the results on this graphic, we can tell that the bid type, the expected revenue, and the market are the most important features for predicting whether or not a bid is late. Our goal here was to find a feature that we could explore deeper and figure out how the feature affects the bid process. Of these three features, we did not explore the expected market revenue because we did not believe this feature has an impact on how the system operates. ArcBest does not have teams for higher revenue bids and others for lower revenue bids. So with this in mind, we conducted further analysis on both the bid type and the market features, but we'll be focusing on the different markets in this next slide. Our initial thought in the fall was if we could find a market that had a lower percentage of bids returned on time, such as final mile at launch, then we could focus on and finding a way to improve those markets. As we explored additional attributes such as percentage of bids and expected revenue for each market, we noticed that it would not make much sense to focus on markets such as final mile at launch because they account for such a small percentage of bids and small percentage of expected revenue. From this preliminary analysis, it appears that it makes more sense to focus on domestic LTL and domestic and Canadian LTL. So in summary, the primary performance metric that we were concerned about in the fall was whether or not bids returned on time to the potential customer. But during our spring semesters, we have shifted our focus away from trying to improve this performance metric and took a deeper look into the bid creation and offer process. So now Ben will talk about where our spring improvement efforts began.
Thanks, Blake. So to start this semester, we realized that we really needed a way to model and visualize how the system's currently operating, and also it would allow us to validate any kind of improvement efforts that we were to do. So what we decided to do was build a simulation model, and due to the nature of the system, we couldn't do time studies, and just the complexities of everybody being virtual, it was hard to get real time. So we got just some educated guesses on the system, from Trenton and Alex and their meetings with them, in addition to the system flow that we had already developed last semester. And so we were able to combine these to create a simulation model. And as you see on the screen, there's really two separate loops in that gray box. The one to the left represents when the pricing engineers are working on a bid. So they could be reviewing it or performing analysis, creating an offer. When those happen, those are times where value is being added. Work is actually being done to a bid. Pricing engineers have it in their hands. They're working on it. Whereas the loop to the right represents when the bid is going through an RFI or RFYS, and those are non-value added activities. So the bids are just sitting there. They're not being worked on, and they're just being delayed in the system because they didn't have all the information they needed to do the process or to review the bid, and so the bids are sitting there basically in a queue in the suspense idle period. So being able to model this really helped us to see where the system currently standing, and as we'll talk about later, how our improvement efforts have improved the system. But the most important part of this process was modeling how each entity's, each of the bids is given attributes. And so we decided on 4 different attributes that were most important to the bids to be modeled. And those are the pricing engineer, the bid type, the sales region, and the market. So if we were to just generate a random number for each of these separately, it would not actually work logically because there's a lot of conditional probability issues that would have come into play. So what we decided to do was go back to our historical data and filter it, sort it, run it through Excel, run it through R, and we were able to just filter out everything except these 4 attributes for each of the thousands and thousands of different historical bids that we had. And so once we did that, we were able to group these into each different unique combination of these 4 attributes. And so after we had grouped those into the unique combinations, there's still thousands of them, but we now have all of the different possible combinations that have actually historically occurred in the system. And we can just take the the counts of times each occurred and create a probability of times out of the total that each of the unique accounts occurred. And from that, we're able to create a CDF. And this is just a small example on the screen of what we did. So the assignment probability, it's just the probability of times that unique combination occurred. You see it does not sum to 1. That's just because when we're cleaning the data, some of it has to be removed because there's missing data. And so this is an exaggerated example. But from there, we just scale that sum up to 1 and then scale it all the way down the list. And that gives us a CDF that actually adds up to 1. And from there, all we have to do is generate a single random number, and that will relate directly to a unique combination of 4 attributes, so we can more accurately model the bids in our system. Now I'll let Jackson talk about our system evaluation a little bit more.
Thanks, Ben. So as Blake mentioned earlier, we decided to introduce some additional performance metrics to better understand the system and to measure our potential improvements on it. Because the part of the system that we're focusing on is pretty small when you're considering the scale of an entire bid, the current performance metric of whether a bid is returned on time or late doesn't really tell us a whole lot about how the system reacts to the changes that we're going to be making. So after running the simulation and looking into the results, we decided that some more descriptive performance metrics could be the simulated number of bids that ArcBest completes in a single year and the simulated average percentage of time a pricing engineer is utilized throughout the bid process. Both of these values for the current system can be seen on the slide. Because ArcBest completes so many bids in a year, even slight improvements to the system should have a visible impact. And also the average pricing engineer utilization is more of a direct measure of our system of interest. So we're able to sort of zoom in on the pricing engineers rather than looking at the system as a whole. Now I'm going to pass it off to Ben to demonstrate how offers are currently created at ArcBest.
Thanks, Jackson. So what we did to show you how offers are currently created is we created a screen recording of us emulating what a pricing engineer must do to create an offer. So what you'll see here is the pricing engineer has an Excel file open, and that is the bid template, which contains all the necessary data and information about the bid that will be used in the offer. And then they also have open a downloaded template of an offer. And so one of the, there's a couple main problems with the way that this works. And the first problem is how manual and tedious it is for the pricing engineer to go through and fill out this template. And along with how manual and tedious it is, it takes a lot of time. It can take anywhere from 20, 30, maybe 40 minutes, depending on the size of the bid and the complexity of the bid, because they're actually having to go through and do this all manually. And that's non-value added time. So that's time that the pricing engineer could be spending doing other things. The other issue with this is the issue of standardization. As hinted at previously in the presentation, if we can create a more standard format that can optimize the processes that use this information later on in the system, such as the sales or marketing team. So between standardizing it and automating it, we think that this is the that we can really improve the system through those two means. And so now that we have like a little bit of an idea of how this process currently works, I'm going to move into talking about how we're looking to optimize it and what our solution looks like. So what you see on the screen here is a diagram showing the high-level architecture of our tool. When we were creating this tool, the first thing we had to do was figure out what the platform for it would be. And so it ended up being a pretty easy answer, given that ArcBest has a current suite of existing tools in both Excel and Access. So what we decided to do was create a VBA tool using Excel that could basically integrate with their existing suite of tools. And doing this also allows for ArcBest to implement our solution very quickly, as opposed to some other potential solutions that might take longer to implement. And so when we were creating this tool, after we decided on using VBA, there were a couple other things that we had to consider. The first was the source of the data. So as I mentioned, most of the data comes from the bid template. The problem that we had, though, was that not all the data comes from here. So the data that's in the bid template can easily be pulled from our VBA code and included in the offer. but we needed to handle some bits and pieces of data that were not in the bid template. So the solution that we came up with was to use VBA user forms and then combine those two sources of data to then render the actual offer. And in addition to the source of data, the other considerations that we had to make were making the tool extensible for ArcBest, as well as handling dynamic data or data of different links. So with regards to making the tool extensible, what we decided to do was compartmentalize the code into a series of functions that we call render functions, where each render function maps to a different section of the offer. So you can see here on this screen, the first render function maps to the top of the bid, which has some basic details about the bid. The second render function maps to the FAK section of the bid, and the third render function maps to the discounts and AMCs. So these functions are set up in a way where they're independent, and if you were to alter one function or even remove the function, it wouldn't cause any side effects and break the code in the other functions. And so that makes it really easy if ArcBest needs to make a change or fix a bug or really whatever. They don't have to go through and sort their way through a bunch of mangled code. It's very easy to find what they need to do. And then as far as handling dynamic data, what we decided to do was instantiate a counter variable that would represent the number of rows that have been used by the rendering processes. So, and we did that in the main function. And then we passed that variable by reference into all the render functions. And then so in each render function, if the render function is dynamically iterating over data from the bid template, it can also dynamically increment the reference to that variable. So for example, if the FAK section were to have 4 FAKs instead of just 1, then the discounts and AMCs section would be pushed down 3 additional rows so they wouldn't collide. And that's allows it to handle bid templates of different lengths, regardless of how much data is in those templates. So now I'll hand it over to Joey, and he'll talk a little bit more about some other difficulties and some other considerations that we had to make when designing our tool.
Yeah, thanks, Ben. So something that was hinted at earlier in the presentation, bids are completely unique to the customer. Customers may always want business done a certain way. They may want to know everything about what they're shipping and how it's being shipped. And they may not want to know anything. They may have been with the company for a long time and trust ArcBest enough to just be like, hey, ship our freight. They may want to price individual zip codes. They might want to price by state, city. They might have multiple shipping locations, or they may not have any shipping locations and only want to ship third party. As you can see on the screen, this is 4 different ways to basically report how you shipped your freight. From left to right, PC group is going to be the location, and tear group is the territory or where the freight is going. But it's city to zip code, city to state, city to region, and then zip code to zip code. And then obviously the list goes on with all the different combinations that you can have. But basically this is to show you that they have these kind of decisions at every single level of their report. And so from a coding standpoint, that kind of provides a huge problem with the fact that we can't just, focus on accepting one type of input for our engineers and then reporting it. And if we want to make it automated, it has to be dynamic, and it has to be able to field any types of these decisions that are made. And just from a formal versus informal standpoint, the informal report is always much more detailed. And so it's even harder to automate that one, because the more detailed, the more problems. Yeah, and so moving into the next slide, you can kind of just see right off the bat the kind of differences that we have just in the first page. The informal bid is going to be on your right, and you can see that it's kind of headed almost like an email, and it has a date due as an input, rather than our formal bid, which has the date due just set to 2 weeks. But also something that you may be confused about at this point, web bids are reported in the same way as informal, so they are lumped in actually with our informal tool. So we only had to make 2. But anyway, the pricing and provisions tab is something else that you're going to see in a little bit that's much different as in comparison to the formal. The pricing and provisions tab is something that was necessary for the informal bid, because we can't just pull a matrix like we could for the formal bid and just put it on the report. We have to get multi-tiered FAKs and et cetera for the informal bid that the engineer has to input. So I think that the specificity of our inputs is kind of a result of the specificity of the bid offer itself. But now I'm going to hand it back over to Ben for a brief demo of our informal user form.
Thanks, Joe. So what we've done is, again, is created a video of us demoing our tool, so we didn't have to do a live demo. And right off the bat, what you're going to see here is the PC grouping and the territory grouping that Joe was talking about. There's a couple of drop downs where the pricing engineer can select the grouping option and then click refresh. And you'll see it changes the format of the data as well as the length of the data. So that's what Joe was talking about when he said we can't just, have it be the same every time. It's going to be different depending on how the pricing engineer selects those options. And so whenever the pricing engineer gets that how they want it, they can click the button which pulls up a user form. And then on the first tab is the bid information. And so this is similar to what Joey was just talking about. There's who the bid's going to, who the bid is from. You have the subject of the bid, the due date to the sales team, as well as the due date to the customer. And then you also have some base rates for both domestic and Canadian. And these base rates are being dynamically pulled from the bid template, so they're not hard-coded. And then this is the pricing and provisions tab that Joy was talking about. On the top, you'll see we have some checkboxes for US and Canada, and then third party. If either US or US and Canada checkboxes are clicked, then the domestic and Canadian section of this page will be displayed. If neither of them are checked, then that section will just be omitted. And same for the 3PL. If it's checked, the third party section will be displayed. For this example, we're going to use both US and 3PL. And then once they select those, they can select a series of modes, mode 1, mode 2, or mode 3. And then for third party, there's just mode 1 and mode 2. And then now what you're seeing is loading into the FAKs. So there's the upper, which is the range, and then the actual FAK, the actual rated class. And then whenever those are entered, they can click the load button, which will load it into memory. And then also, in addition to the FAKs, or the ranged FAKs, they also have an item specific FAK. So I'm obviously entering in a fake item number, but the pricing engineer could enter in a specific item number and then the FAK associated with just that item number, and then load that into memory as well. And the same thing can occur for the third party. And so it's also important to know whenever we're click these load buttons, we're loading them into a collection and saving them in memory so that they can be used later on in the process. And then just loading in again for the third party and item specific FAK. And now we're moving to the accessorials tab. So the accessorials tab is very similar to the formal bid. It's actually identical, and it's important to know we don't have all the accessorials listed here. These are also being dynamically loaded from the bid template. So we just have a couple of them in the bid template, but they're very easy to add because they're being dynamically loaded in. And so whenever a pricing engineer wants to add an accessorial, they simply highlight it in the list box and then click the add button. It'll add it to the right. And then if they want to remove it, they highlight it and click the remove button. And then by default, they're NC, which stands for no charge. But if they want to add a cost, they can simply change it. And so this next tab, this is the other considerations. This is a bunch of legal language. And so if you can think back to the beginning of the presentation on the swim lane diagram, you can remember that we talked about how a formal bid goes to the marketing team before it goes back to the sales team, whereas an informal bid does not. And so with a formal bid, the marketing team will add a bunch of legal language to the bid or the bid package, the offer, before it goes back to the client. With the informal bid, that's not the case, and the pricing engineer is really the last check, and they have to add all that legal language themselves. So in order to kind of automate, as much as we could at least automate that process, we created a series of checkboxes that the pricing engineer can simply check to add that language to the bid or not check it to omit it. And then if they're not sure what that language is, when they click it, the language appears on the right so they can see an example of what that language is. And then whenever they get the bid the way they like it, they can click the button at the bottom of the form, and it will create a new tab in the Excel workbook with the formatted offer. And so as you can see, took about 4 or 5 minutes as compared to what could take 20 to 30. So it's a huge improvement. So I'll now hand it over to Blake, and he's going to wrap up discussion about our tool.
Thanks, Ben. So our goal when creating this tool was to make something that was both dynamic and flexible. The image on this slide is a tab in the Excel sheet that we have created. Each header in row 1 of the sheet maps to a part of the user form where a drop-down list is used. So for any reason, a new base rate or new accessorial needs to be added, ArcBest can easily go into this sheet and add a new cell to that needed column and add the needed information. So the tool itself has a small amount of hard-coded information in it because our tool utilizes pages such as this tab as you see on this slide. And by getting information straight from other parts of the pricing engineer's analysis that's completed in the Excel workbook, the dynamic nature of the tool gives it the ability to handle many different scenarios that pricing engineers may encounter while working through many different bids. For example, the use of counters and other functions will let pricing engineers include as many or as little different FAKs that a bid may require. The code being flexible also gives ArcBest a chance to make fixes to problems that we may not personally see right now, and allows ArcBest to make changes to the tool prior to it being implemented to the entire team of pricing engineers. This tool will significantly reduce the creation time of the bid offer and increase the quality of life for a pricing engineer. But now I'll pass it off to Jackson, who's going to discuss what we think the potential impact of this tool will be.
Thanks, Blake. So since we won't actually be around to see ArcBest implement the tool, we won't be able to measure its improvements on the system directly. Because of this, we decided to simulate the system as we expect it to operate with the tool implemented so that we can predict these improvements. To simulate the system with our tool implemented, all we really had to change in the simulation was the amount of time that it takes to create an offer. We assume that our tool will allow pricing engineers to create offers in about 25% of the time that it takes them now, which works out to be like 5 or 10 minutes. After running analysis, we found that this step of the process, or that the process as a whole, is relatively insensitive to changes in the amount of time that this step of the process takes. And when we looked a little bit deeper, we found the reason for this is the information request bottleneck that occurs earlier in the process before pricing engineers are able to analyze the bid and create the offer. Bids get so clogged up here that improvements to the system later on down the line are kind of hard to notice. It's sort of like if you were measuring the water flow of a creek from downstream and then you had a big dam upstream and you shifted around a few rocks in between. Now, it might have improved the water flow a little bit, but improvements are going to be limited until somebody addresses the dam. And I don't say this to diminish the work that we did in any way. ArcBest specifically at the beginning of the year said that we were looking for small wins, maybe in the form of standardizing or automating some of the pricing engineers' work. And so that's what we've done with this tool. And additionally, like Blake mentioned, a lot of the improvement from our tool will be more toward a quality of life improvement for the pricing engineers. So it goes deeper than just the quantitative improvements. But looking at the numbers on the screen, there are a few important things to note. For one, although the pricing engineer utilization goes down, more bids are being completed, which seems counterintuitive, but it actually makes sense when you look at how the system operates. Pricing engineers are able to do their jobs in less time than they were before by using our tool, but they can't start their work until the sales team gathers all of the necessary information through that information request bottleneck that I mentioned. So they can't always immediately begin working on another bid after they finish working on the current one, which explains why their utilization does not increase. It's also important to note that 2.1% more bids being completed is more impactful than it seems. Simulating a year of operation shows 65 more bids being completed, and depending on the length of a contract, expected revenue from a bid can be a few $1,000s or hundreds of thousands of dollars. So this could be potentially millions of dollars of additional revenue every year for ArcBest. Before we retired the simulation model, we wanted to use it to give ArcBest an idea of where they could direct future system improvement efforts and predict the potential impact of those efforts on the system. And so we had a pretty good idea of where to look. We wanted to look into that big dam that I mentioned in the analogy, or the information request bottleneck, because this is where we see the most potential for significant future improvements. So currently the maximum number of RFIs a bid may require is 20. which we believe can be significantly reduced. We conducted sensitivity analysis on the maximum number of RFIs, and the results can be seen on the table on the slide. The percentages to the right are incremental and represent the approximate improvement to the system every time the maximum number of RFIs is decreased by 1. For instance, if ArcBest could make it to where the absolute maximum number of RFIs a bid may need is 19 instead of 20, they would see approximately 1.3% more bids completed. Bids would spend about 3.1% less time in the system, and pricing engineers would be utilized around 1% less. It's easy to see how quickly these percentages can add up and why ArcBest may want to direct future system improvement efforts in this area. In conclusion, bid processing is a very complex process involving many different people and departments, and because of the complexities of this process, the quantitative improvements that our solution have on the system are limited, but the system is undoubtedly improved. The VBA tool that we built will streamline the offer creation process and save ArcBest a good amount of time and money on bids annually. And also our tool, like I mentioned, will be a big quality of life improvement for the pricing engineers, considering how manual and tedious the offer creation process is right now. Other people will get to reap the benefits of the tool as well. Other people involved in the process at ArcBest, specifically the marketing team. Our tool introduces standard for the way that bids appear. So when the marketing team goes to dress up bids prior to presenting them to a customer, information will always appear in the same place rather than it being specific to which pricing engineer created the offer. So after the implementation of our tool, bids will spend less time in the system. Pricing engineers will only be utilized for time that adds value, and ArcBest will create more bids each year. That concludes our presentation. We would like to thank ArcBest, specifically our contacts, Trenton and Alex, for their help throughout the process, along with Dr. Cassidy and Dr. Schubert for their guidance. Thank you.